Hi, CEA. So I'm going to go over the home development test questions. There are 5 of them. Sorry, see if I can get cool. There are 5 of them. We'll start out with the zoning questions. We'll just go through them one by one. These are the same questions that you would see in Kite, but I just copied them and I put them over to a document so they're just a little bit easier to work with because the Kite portal is set up to mimic a testing site where you can't have access to anything else. So this, you can watch the video as I go over them. Right here, these questions are over home development, and all it is can you look at this data and can you apply it to your house? So I kind of have to understand what the data is. So a lot of it's testing your vocab. So if you look here at this chart, it's zoning districts. You have to read this paragraph up here. It just says the property is located in zone R1, which is for residential single family dwelling. Okay, so we have this Unified Development Ordinance for residence districts is shown. So we have, for an R1, the site requirements, the maximum floor area ratio is 30%, and that's 30% of the site. So that will have to do with question 2. And then we have these numbers down here, which are setbacks. So you can see that they're right here, the minimum building setback in feet. The front, the rear, the interior, and the street side. So the front is the front of the house in this case, and it's also the arterial streets. So this arterial street right here, these 4 are your options of choices here, and the arterial street is like the main thoroughfare that's going to be having all the cars, and you can see that the neighboring properties are just neighboring houses. So it says, okay, based on the information in the chart, where should the house be placed on the property in order to adhere to the ordinance for proper location? So you can see that one of them is going to stand out more than the others. I'll go through the ones that are wrong. You can see that option B is incorrect because the house is too close to the neighboring property. If that was your property, that square in the middle, you couldn't have your house be built there because you have to have a setback from your other properties. Okay. Same thing with D. You can see that's way too close to the neighboring property. C, you're like, oh, that might work. The only actual area it doesn't work is the arterial street. You have to be farther back from that, so that will not work. A is your only option that will work where the house is located in the property. Okay, you can kind of see this a little bit when you go through neighborhoods where some houses might not be located directly on the middle of their site. Some side yards are larger than other ones because 2 houses choose to maybe move to the side and create a larger side yard, and then have one side of the yard just be focused on maybe the driveway or something. Okay, so that's question 1. So question 2 says, based on the excerpt from the Unified Development Ordinance, what is the maximum floor area in square feet allowed on the lot for a single-family residential structure in R1 zone? So enter your answer in the box. So this would just be enter your answer in the line. If you look at the property, we have a 200 by 200 foot property here. And when you multiply that together, it's 40,000 feet. And what's 30% of that 40,000 feet? Well, that's 12,000 square feet. So you could build a 12,000 square foot lot right there, which is a lot, which is pretty big. So, but that would be allowed in the ordinance, 30% right there. Okay, so that's the maximum size footprint. Number 3, which feature should the homeowner add in order to best reduce noise on the property from the arterial street? So the street that cars are moving through, there's going to be the most noise pollution, I guess you could call it. It says a roof with a steeper slope, raised flower beds in the front yard, immovable shutters attached outside each window, or a solid wooden fence around the perimeter of the property. So which one best reduces noise to property? Probably the one that I would choose is probably not the best option. I would probably say raised flower beds, just because the look of it, it's not, it's better than the best option for reducing noise. The best option for reducing noise is a solid wooden fence around the perimeter of the property. That's going to reduce the noise the most. The steeper roof, it might have some deflection of the noise, but not really. And the movable shutters that are removable, if you can't close them or open them, they're just there for aesthetics, so they're not doing anything for sound. But the solid wooden fence is the answer there. Even though I would pick probably the raised flower beds that would impede the noise, and it doesn't like it has I prefer that look better than a solid wooden fence around the entire property. But that's not what the question's asking. Okay, so number 4, it's kind of a lot, and I think that they kind of messed up on this question because they don't give 100%. They don't give the enough information to get exactly what they got. So I'll show you what I'm talking about. So it says the site was originally farmland. A 30 by 40 foot home with an asphalt shingles roof is built on the property. The remaining property is left as farmland. The table shows information on precipitation for the area. I added 2 other tables because when you're taking the test, you will be given a packet of formulas and things like that. So the 2 other tables I gave you would be tables that you would be referencing for this question. But they give you this chart over here for the rainfall. The reason why they give you that rainfall chart is because that's the thing that's going to change the most based on where your house is located. So because you have different areas of the country, geographically, it rains more or less, right? So this table will look differently from wherever you are. So they're talking about, well, we'll go down and we'll look at the actual, like what it's asking. It says down here, it says calculate the change in rainfall runoff in cubic feet per hour for a 25-year, 1-hour storm after the property is developed. Enter your answer in the box. Okay, so it says calculate the change in rainfall runoff. That's what we're doing. So we have to have the change, which we have to say, okay, there's a runoff before we develop, and there's a runoff after we develop. And the runoff is, remember, it's raining, the ground either absorbs the water or it displaces the water. So it absorbs what it can absorb and then displaces. So ground always does this, no matter what, even if it's really highly absorbent. If it's raining a lot, it can only have so much, and then it will displace the rest of the water. So you can kind of see, started out as farmland, which is very absorbent soil. It's meant to be that way. And that would be, if you look at this chart here, the farmland is 0.05 to 0.3 on this coefficient of rainwater absorbing runoff kind of deal. It says in the question to calculate the pre-development runoff. The average coefficient is used. So you take the average of 0.05 and 0.3, which is, you add those together, divide it by 2. 0.175, you round it to 0.18. And then you take the highest number for the post-development, which is up at the top, and it's asphalt, which is 0.7 to 0.95. So you take the 0.95 there. And you're like, what is Mr. White talking about? So remember, this is going back to the runoff. So I put all this stuff right here is stuff I've added to kind of help with this question. So we're looking at this formula here for runoff. Q is equal to runoff. C sub F is a factor that's added in for the intensity of the rainfall. And they give us the intensity. It's a 25-year rain. So this is a rain that statistically should only happen once every 25 years. So it's pretty heavy rain. So that's why it's 1.1. And that was up here in this runoff coefficient adjustment factor. So the 25-year, it's 1.1. Anything under 25 be 1, so it wouldn't really have any impact on this equation. C is going to be for your coefficient for your runoff. So that would be the for farmland, 0.18. I is going to be the intensity of rainfall. It's a 25-year, 1-hour storm. So if you look at the chart, it's a 2.3 there. And then right here, just 1 hour, 25, 2.3. Okay. And then I took this is where I think the question didn't give enough, but 30 by 40 foot home, I took that square footage and I turned that into acres, which you should do that as well because this formula is meant for acres. And then I completed the formula. So I got for the pre-development runoff was 0.013, and the post-development is 0.067. And this makes sense in a way because, hey, my runoff is not as great anymore. My absorption level, my runoff increases, and that's not good. Okay, I increased it when I add an asphalt ceiling because roof because that's what it's for. It's not supposed to absorb the water. Okay, it's supposed to deflect the water, so it increases. The only problem is I think this question was they should have given you an actual lot, an actual size of the whole area that this thing is on. Okay, it doesn't say anywhere, or maybe I missed it, that this lot is on 2 acres or 3 acres or whatever. They just give you the size of the building. So all I displaced was the building. Okay, that I'm assuming that I have to assume that the building is the lot. So the runoff for me, for what I would say the change in runoff would be 0.054. However, the answer that they are looking for is 0.37. And this matches as if it was on a 3-acre lot. So if it's on a 3-acre lot and it does this, then it kind of matches this number here, which is similar to one of the example questions they gave you, but they never said anywhere it's on a 3-acre lot. So if you're just looking at this, these numbers here, which would be the right way to do it, then you'd get 0.054. Now this is all under residential runoff if you wanted to look on my project Lead the Way. Okay, I think it's like 2.34 residential runoff, I think. Okay, so number 5, question 5, which method is the best way to reduce rainwater runoff after the site is developed? So this is something that makes sense and you will see it everywhere if you actually pay attention, but in an area where there's like a huge parking lot or a big building or something like that, probably pretty close by there's a park or there's a graveyard or there's a retention pond, like a pond with a fountain or something like that, or a green space, because when developers develop the area, they have to supply an area where that runoff is not going to increase. So when you're buying a lot, you can't just say, okay, I bought this big lot, now I'm going to pave the whole thing and put a building up. It's like, no, you actually have to buy a certain area if you're like a commercial developer, and you have to say, okay, we have to save this spot over this area over here to collect the runoff that we're displacing. Okay, so the best method to reduce runoff in this situation is add a concrete driveway? No, because that would be actually increasing runoff. Add a patio in the backyard? No, that's probably increasing runoff as well. And add an awning to the house? That's increasing runoff. So the only one that's decreasing runoff at all is to buy a retention garden. So garden, that's going to be the option right here, B. All right, so hopefully these make sense, and we've answered questions. And see if you can prove me wrong on question 4, and if you find that there is information there. All right, take care.